Hello, my name is Rob Garner. I'm a computer programming instructor, and today I'm going to demonstrate how to read a file from, or how to read data from a file in C++. So I'm going to start a new project. And I'm going to call it DataDemo. So we'll make an empty project. And to start, let's see. In this program, we're going to need a file to read. So I'm going to right-click on DataDemo and open up the file. And I'm going to drag in my text file. In this case, I grabbed some weather data from Tijeras, New Mexico, and we're going to look at this file to begin with. And I recommend using Notepad++ to look at a file. And if we look at this file, one of the things with Notepad++ that's useful is we can look and see what kind of encoding this file has. In this case, it's UTF-8. UTF-8 works well with C++. You have to do other things for UCS2. So if it's a UTF-8 format, then that works fine. In addition, the other nice thing about Notepad++ is under View, we can show all characters, and that's important when we're reading a file so that we know how this file is put together. And we can see in this case that the first line of this data file is a header row, and that each line is ended with a carriage return line feed. That's treated as just a single line feed for the most part. And we can see that there's no line feed at the end, which will be important because that tells us that once we read this line, we don't have to consume a line feed. Now, if this file was a CSV, for example, I'm going to rename this to which it could legitimately be treated as a CSV. You'll notice that it'll change, and if you have Excel installed on your system, if you double-click this, it'll open it automatically in Excel. This is not necessarily extremely useful because it's even though it's nicely displayed, it doesn't really tell you how this file is constructed. So even if the file you get is a CSV file, I recommend looking at the file in Notepad++ just so you can see what the structure of this file is. I'm going to change it back to TXT. Once we have this file in our project, you'll notice that it doesn't automatically show up in your project directory. So what we have to do is add an existing item, and then we'll find it here in our project directory. If you add it, you'll see it's visible here. So to begin with, let's see if we can open up this file and display its contents. So I'm going to start a C++ program. It's of course called DataDemo. And we have our normal startup here for a program. And then what I'm going to do is I'm going to create a string, and we'll just say this is what we're going to read our data in. And then we're going to create an ifstream object. Now ifstream, in order to be able to use ifstream, we have to include the fstream library. Fstream gives you both ifstream and ofstream. We're going to use ifstream to read our file. And once you create your file object, the next thing you do is use the open method of the ifstream class to open your file. And in this case, we're just going to open this file here. And I recommend using cut and paste as much as you can to prevent spelling errors. So we're going to open up that weather file, and we're going to check to see if infile.is open. And what is open does is it returns true if the file is open and returns false if it's not open. And it's entirely possible that when you open this file, it's not open. It may, if it wasn't there, it wouldn't find it. And so it's important to check your file to see if it actually opens. And so in there we're going to do some stuff, but if it doesn't open, what we'll do is we will just see out an error message. So if it opens, we are going to work with the file. If it doesn't, we'll output an error message. And just to keep it simple, we're going to basically do a while loop, and we're going to do a get line. And what this get line will do is read in one line of data at a time into this file. Now, if we're going to use get line with a string, we have to include the string class. And then we'll just output whatever we get with that get line. And this will just keep going through. Now, if we don't get anything from getLine, what getLine will return is an empty string. It's something that looks a little bit like this. And if getLine doesn't successfully get anything, this will return false, and it won't do the cout, and it will drop through and continue on. So this is one way of reading through a file. And once we're done working with the file, you want to make sure that you always close the file. If you don't, then it will leave that file open and another program can't access that file. So you always have to close the file. So that's the basic process of working with a file. And let's see if it works. And it does in fact work. In fact, here's what we read in with the program. And then let's see if we can find the file itself. And we can see, yes, it did in fact read the file. In fact, we can see there's the header row that showed up right here. And then 12:15 is the first 12:15 a.m. is the first element. And the way this reads, it actually just reads everything in just a line at a time. So it's with the getLine reads all the way till it gets to the end of line, which is this end of line character. That's the default behavior of getLine. And this works fine, but we're really getting, we're not really storing it in anything that we can actually do any processing. We can't do any math with any of these things. These are all text strings that we're getting in. So we can't really use this like this at this point. So we need to do some more work. And one of the things we could do is we could move all this code into a function. So I'm going to create a function, library, and maybe we'll call this file functions. And I'm going to create a header file. And we'll start off our file function with some imports and our and of course we should include our library file. And so we're set up now to make some functions. So I'm going to take, I want to make a function that that will open up our file, read the data, and then return that to us as an array of lines. So, and we'll use a Boolean return result, so it will tell us whether or not it successfully opened up the file. So we'll call this read data, and I'm in file functions.cpp. And we're going to bring in the file name as a parameter and an array of lines. Realize that arrays come in automatically as references. So when we bring in this array, when we modify that line, whatever array was passed in will be the one that will receive the results. And then we're also going to return back an integer variable that we're going to bring in as a reference so that we can send back how many elements we actually read. And that's important because, while we're going to pass in an array that's large enough to carry whatever we read in, we need to make sure that we report back how many elements we actually read. And so I'm going to grab this code here, and we'll put it back into this function, and then we'll modify it. And so now, I don't want to output this data from the file. What I want to do is I want to put it into this array. So in order to do that, then what we're going to need is we're going to need a variable to keep track of which row we are currently on. So we have rows, which is how many total rows there are, and row is just going to be a variable, which will basically be a counter that will go through, we'll use as an index. And then rather than the cout, what I'm going to do is I'm going to say lines at that row is equal to text. So when we read in this text line, it's just going to store it in the array. And then once we're done, we will increment that row. So now that what will happen is I'll read through the file line by line and store each line of data in one element of this array of strings. So each element of this array will eventually have a line from the text file. When we're done, we're going to close the file we're also going to say that the rows is equal to row at this point, because as we loop through and we increment row, finally at the end, row will have the total number of elements. And we can just store that in there. And then we'll just return true so that we can report back that this actually successfully read the file. If it doesn't report true, then we're just going to return, if it doesn't open the file, we'll just return false here. And notice that in this function, we've taken out any couts. And so with a function, often what you want to do is you want to do all your outputting from your main program or a output function for your main program, but you don't normally want your utility functions to actually write directly to the user. You want to leave that up to main. So in this case, this function will just return true or false to indicate whether it read it properly, and then main will figure out what to report to the user. So what else do we need to do? Well, we don't want to hard code the name now because we have a file name, so we're going to replace this reference to the file name here. So it uses the file name that's passed into this function. Now that we have our function defined, of course, never forget to copy and paste your function prototype over to your .h file. And I always recommend only copy and paste to your function size. Don't edit the prototypes directly in .h. You'll invariably make a mistake and there'll be a disconnect between these two. So to avoid having the problem of these becoming disconnected, just copy and paste. Now in main, we're going to use this function. So, we'll need to declare a few variables to begin with. First of all, we're going to need to pass in a file name. So I'm just going to declare my file name again. I'm going to just paste it in so I don't make a spelling error. I know that file has a little less than 100 lines in it, so we'll declare our array of 100 lines to make sure we can read everything. You could also use a vector instead of an array. A vector would be infinitely expandable, so if you did this with vectors, it might even work a little better. And so the first thing we want to do is get lines from our file into our array. And to do that, since we have this nifty function, we're going to call that function. Now that function returns a Boolean, so I'm going to store the result of that in a Boolean variable for use in a bit. And so then I'm going to call that read data function. We're going to pass in the file name, lines from the file, and the count of lines variable. So we're passing in this, and realize that count of lines comes in as a reference. So what we're really passing is the address of this variable here. Lines from file is our array. It's implicitly passed by reference, so this is also coming in as a reference. And file name, we're just passing that in directly. You have to spell it correctly, capital N. And so that's being passed by value. So this is passed by value, that's by reference, and that's by reference. And note, in the parameter we defined it as lines. Here I'm passing in an array that's called lines from file. It doesn't matter that these names are the same. What matters is that the arguments here in the function call match the type of the parameter. So in this case, lines from file is an array of string, and this does in fact ask for an array of string. Count lines is an integer, and this is looking for an integer, a reference to an integer, which is what this is. So the names don't have to line up between the function call and the function definition. They just have the arguments must match the parameter types, however. So now I'm going to check that the result from this read data. We're going to see, and so if this read data comes back okay, we can just check to see if it's okay. Now, I could do this by saying equals true, but it's redundant because b file okay is by itself is an expression that returns true or false since it's Boolean. So we can just do it that way. And then what I want to do is if it opened okay, then I just want to display the lines. And to do that, I'm just going to loop through this array and see what it has. So we'll do a for loop. And we'll just output those lines. We index a line using our loop variable, and this will go through each element of this array and display what it has. So if this read that successfully, it will have what's in the file. If we can't open up that file, then the b file okay will be false, and so we'll just output a message. And maybe we'll display the file name here. And so it'll tell us they couldn't open the file. So let's run this. And it does, in fact, open up and read the file. So we know that our function is working. Watch what happens if I change the name. So I'll change it slightly so it can't open it successfully if I run it with the wrong file name. It says could not open the file. So we know that our file check works and tells us if we can't open the file. So that's good, but now we have an array of strings, and it's not, let's say we wanted to calculate some averages, maybe the average temp and the average humidity in Harris. We couldn't really do that easily with this because we'd have to go through this and we'd have to pull out, maybe use a search for a string in a string in order to find the element we wanted, and that's not very practical. So maybe what we want to do is change our function. So we're going to look at this read data. It might be better if we could bring back maybe a string array of elements for time and a float array for well, we'll start off with dew point. That's one of the elements. And if we look at this data, we can see that the first element here, that corresponds to the time. And then the next element is temperature, and then the next element is dew point. So I'm going to look at dew point just because it's two in. I want to show you how you skip over elements, but eventually we're going to grab temperature and humidity. And so now we have two arrays that we want to read into, and these will be called parallel arrays. In other words, the element at 0 on time will correspond to the element at 0 in dew point. And so now we can't read this way, but what we need to do is we need to read this element and then this element. And so we got to skip over one to get there. Well, the way we can do that is using a variation of the getLine function, which is called a delimited read. And right now we're reading this form of the getLine function reads the entire line. But if you put a delimiter, and in this case we're going to use, since this is separated by comma, we're going to use a comma. By the way, if it was a tab, you would use a \t like that, and that would read to the tab. But since this is comma versus tab delimited, we're going to just say read to, not the entire line, but read to a comma. And then what we'll do is, the other aspect of this file is we can see that we have this header row right here. Well, that's not going to bring in the same values as this, so we kind of want to discard this whole header row. And the way we can do that is we can actually, if we successfully open a file, we're just going to do a get line. And what this will do now is it'll read the entire line, first element here. This whole thing will be read into text. And then since we're doing it immediately after another get line, basically we're just discarding that first line so that we get it out of our way. Now at this point, text really doesn't describe what we want. So I'm going to rename this. And the way you can rename that is under Edit. Let's see, we have Refactor Rename. And you notice there's a shortcut key, which is Control or Control R. And so it's a good shortcut key to remember. So I'm going to hit Control R twice. And I'm going to rename that to temp. I think it makes more sense to think of this as temp. With the refactor rename, it'll identify all the areas where it'll do the rename. If we apply it, this is now called temp. And so really what we're doing is this variable, we're going to temporarily read in a line from the file, put it in temp. Then we're going to read the next one. And so this first line in the file will now get discarded when we read it, and it'll start reading with this element, with this read to the comma. This will be the element that it reads in with this line here. So this discards this whole section here. Then when we start actually looping through our reads, it'll start off by reading to the first comma. That's the first comma. Now that we have that, we're going to take that, and if it reads okay, that means there's something here. Then we're going to read this into, we want that to go into this time array. And then we want every second element to go into the dew point. So we're going to put this into time, which is this array here. And then what do we need to do? Well, what we need to do now is we've read this element in. We don't want this one because that's the temperature. We want the dew point. So we want this one here. So in order to get rid of this, we can't just ignore it. We have to read it in. And so we're going to do another one of these get lines. And if I do this, this will skip temperature F. So we're going to do one just to read it. If you read it and you don't use that variable, then it just gets rid of it. And then what we'll do is we'll do another get line. And this will actually read dew point. Since we want to keep that one, we'll then just say dew point index, our row variable, which starts off at 0 and then we'll keep incrementing. We'll take this temp variable and store it into that row. But there's a problem. Temp is a string, but dew point is a float. Well, we can use our we have stoi to convert a string to an int, stof to convert a string to a float, and stod to convert a string to a double. So we'll use stof, since it's a float, and convert that string that is temp into a float and put it into dew point, into the dew point array. Now at this stage, we are kind of done reading this row, but we can't just start looping back around because the read pointer is sitting right here, and there's still this whole line. So we still have to consume this whole line. And the way we can do that is we do a get line from infile, and we read it into temp, but we don't do a delimited read at this point. We just do a regular get line read, and what that will do is it'll read everything to the next carriage return and just consume it and get rid of it, and that makes the instruction pointer start back fresh on a new line. This is what you have to figure out how to do when you're reading your files. You have to make sure that each time you start your loop again, that you're starting at the beginning of the next line. And then we'll increment our row so that next time we put something into our arrays, we're putting it into the next element and not just overriding the same element each time. So once we do that, we'll take our function prototype. We're going to replace what we have here. So now our function prototype matches our function. Noted that I copied and pasted. I didn't just go in here and fix it, because that you'll invariably get it off and you'll be troubleshooting for a long time to figure out what the problem is. So just copy and paste these over, and then in driver now we have to declare some different arrays. So we need we're going to need a variable to store temperature or time, I guess, and then we're going to need a float array to store dew point, I guess. So now we got these two arrays, and we're just going to pass those arrays into this function now, because it now requires two arrays. So now we're following the new prototype, and then to display it, we'll have to modify our code down here. So now we're just going to show the time and the dew point. And so I'll run that. Let's see if that works. And it does. And so what you can see is now we're reading going through our read file is reading these two elements, not the entire line, but the actual elements that we want. Now, the other neat thing is that now dew point is an array of floats. If we wanted to calculate an average, we could do that. If we wanted to find the max, we could find the max. If we want to find the min, we could find the min. So we could do all of those kinds of functions. We can do math on this function. So that works pretty well. Let's see. But let's say we wanted to read this entire file, and let's say there's a lot of data that we wanted to work with. And we would have to create 15 different arrays. We'd have to create them all in main. We'd have to pass them to this function to make a really long function, and that would be somewhat inconvenient. What would work better is if we could create a struct. And so what I'm going to do is in my .h file, I'm going to create a struct. I'm going to call it weather. And we'll use that struct to store the data. And just to make it easier, I'm going to just reuse from this file these names here. And I'll make these into variable declarations in a second. You could type these names or make your own names, but it just makes sense to just reuse the names they used in the file. And then we have to, when we define a struct, we have to have our identifiers, but we also have to have the type names. And so the way we will do that is we need to look at this data and see what are good types to store that. So time, maybe I can do this. So time looks like that would be probably a string because it's got this text in here. So I'm gonna make this one a string. Let's see, temperature, that looks like it's numeric. We could probably use a float. Float for dew point, a float for humidity. So next two are floats. Wind direction, south southeast. You see that's probably going to need to be a string. Wind speed. First it looks like that should be a number, but we can see down here they start using strings. So I'm going to just make that one a string. If we needed to get the number out of it, we would have to do some more error checking before we could actually turn that into a number. Precipitation in inches has NAs in it, so that's got to be a string. Conditions have to be a string. Events have to be a string. Wind direction degrees, that looks like that's always going to be an integer, so I can make that one an integer. And then date UTC, well, that suggests a string because you have these dashes and these spaces, so that one will be a string. So you have to go through your data and you have to figure out what type it's going to be read in, and you can make a struct to hold that data. If I go to file functions now, I've got my read data. You know, if I wanted to read all of the columns, I would have to make all of these elements in my struct. There'd have to be a separate array for each one, and that would be problematic. But with if I do it this way, I could just make one array of weather objects. And now I just have one array rather than a lot of arrays. But then the question is, how do I read that in? Well, it's just an extension of what we did before. It's just that we're going to have much more in it. So we're going to read in temporarily. We're going to do this read in and see if we get anything. And if we do, then rather than time, it's going to be our weather data object. But we also have to identify, because weather data.row is just an entire weather object, we have to identify which element we want to put this first one in. And so that's going to be our time MDT. That's going to go into there. Then we'll read in a get line. And I'm going to get rid of most of this temporarily. And so then we do a get line, and we read the next one in. And we're going to do sort of the same thing here. We're going to do a weather data row. The next one goes into temperature. And if we just do temperature temp, this temp variable, well, it's a string, and temperature, though, is a float. So we have to convert that to float, and we can use our STOF function to convert that to a float for this one. And the next 1, 2, 3, 4 are this structure. So I'm just going to copy this. We'll get rid of this comment because it's not relevant at this stage. We're going to read everything in now. There's no skipping. 1, 2, 3, 4 of these. And then I just have to change. Oops, that stayed the same. This is the first one changed. The next one will be dew point. The next one is humidity, sea level, now we have a bunch of strings, so that's more of this format where we don't use STOF, we just read directly into the variable. So after visibility, we're going to get wind direction. And we'll just copy this. Oh, we forgot the get line part. That needs to be here. And then let's see how many more of those. 1, 2, 3, 4, 5 more of these. So we'll copy 5 of these. 1, 2, 3, 4, 5. And you could just do this as well. think I'm missing one. Let's make sure we've got this correct for the string ones. So we have visibility, wind direction. Oh, we have this twice. So fix it like that and change this one to conditions. So now we're down to here, and got two more to read. This one we're going to read into wind direction degrees. It's an int though, so we have to take this and use the stoi function to convert that variable into an integer. And then the last thing that we're going to read is date UTC. Now, this would be fine, but the problem is that we've now read our last element. So we've read all the way up to here, but we haven't consumed this carriage return. So there's this carriage return sitting here, and we have to consume it. Otherwise, what will happen is when we start reading again, this will be read as a blank line. And in fact, I'm going to leave it like that for now just to show the problem. Let's see if it works. Now, I need to change my function prototype because I changed the function. I'm going to copy and paste it in again to my header file, which then, of course, changes this. So now we are going to not have a string of time and a string of dew point. We're going to have an array of weather objects or weather structs, and we only need to pass it, and we'll call this wdata perhaps. And so now we pass into this function an array of weather data, and then the question is if we get this weather data, how do we display it? Well, wdata is the array. We're going to use our index variable to get each element, but then we just have to pick what we want. So we could say, let's say we'll display the date UTC, and then dot. Well, first we have to index our array, then we put the dot, and let's see. Let's do something else that we did before. We'll do wind direction degrees. So you can see now you can pick whatever you want to display because you're reading in the whole file. If we run this, let's see what happens. We get an error. And if you get an error like that when you're running this, just run in debug mode. I'm going to hit F5 and run in debug mode. And it'll bring us to, when you run in debug mode, it'll stop right where the error is. So I'm going to break, and let's see where we're at. It stopped right here. And it tried to read visibility and tried to convert. It had trouble converting temp. Temp was south. So let's see. That suggests there's a problem reading this value in, and it's off kilter. So let's see what our data looks like. Visibility mile per hour. The value says south. And that means that it's trying to read this value into visibility. But that's not visibility. That should be in wind direction. So why is it one off? And we can see it actually didn't have any problem reading the first row. And this is kind of hard to figure out. But if you click on this element here, this is the actual weather data. We can see that the first one read in just fine. Wind direction came in here. But on the second one, on the current row, wind direction was trying to read, the wind direction south was being tried to read in here. And the reason that happened is this. Remember how I said that you didn't consume the carriage return? Well, because you didn't consume the carriage return, what ended up happening is it read all the way to just before this carriage return on the first row. Then, when it did the read that ordinarily would have been reading this element right here, it instead read the carriage return into that first element. And so you'll see, if we look at this, that time MDT ended being 61.9. That ended up being this one. So it got one off. So we have to fix that. And the way we can do that is when we read this last element in the data row, we don't want to do a get line and read in this to the comma, because in fact, I'm going to run it again and show you what actually happened here. So abort, run in F5 mode. If we look at weather data, we can see that the last element that was read in is date UTC. Because we read to the comma, when it was sitting here and trying to read this date in, it ended up reading all that. Well, that carriage return is not a comma. This is the next comma. So it ended up reading all the way to here. And that whole thing, including the 12:35 a.m., went into date UTC. And then when it started reading the next row, it started one off. So we got offline. To fix that, it simply is a matter of making sure that the last thing you read is not a delimited read, but is a read to the /n. So you got to pay real close attention what you're reading to. In the last element, if we are reading in the last element, we must read to the carriage return and not to the comma. If we do that, we can see now we read everything successfully. So those are some of the difficulties and complexities. So when you get to the end of your line, realize this is all reading, this is all to read one line of data if we're reading all the elements in. And the last element you must read to the /n, not to the comma. So now we have a function that can read our data successfully, puts it into an array structure. We're getting all the data, and we can do anything we want with the data. So let's see if we can make a few functions that will process that data. Well, one common function would be figuring out the average. So I'm going to do that here. I'm going to create a function called calc average humidity. And we're going to pass in an array of weather data objects. We're going to use the square braces for array. And of course, we need to know how many rows that are valid in there. And then what we can do is, it's pretty simple. For an average, what you do is you put in the total. Or we're going to initialize a variable called total, and we'll start it off at 0. And then we'll just loop through our array of weather data objects. And we'll just accumulate. So we'll take whatever, each time we look at an element, we'll take what it was in total before and add to it whatever's in our weather data. So that indexes, gets the element in the weather data, and then we have to hit the dot operator to find the element of that weather data struct that we want. So that we're going to get the humidity out of that index. And once we have that, then the average is going to be equal, we'll make a float for average, is equal to the total divided by the number of elements. Well, the number of elements is the number of rows. And that will be our how we could figure out the average. Now you can, if we want to simplify this, we don't really need to put the calculation into a variable and then return that variable. We could just do this. And so you can make your last, you can just return that expression, and that will be the average. And another efficiency that we can do is, rather than doing total equals total plus, that's the same thing as just saying plus equals. So that makes it a little bit more elegant, a little cleaner to write it that way. So this is our calculate average function. And then again, once we finish our function, we copy the prototype over. Don't forget the semicolon at the end to our header file. Once we have our header file, then we can now call this function. So in here, maybe what we could do is here we'll change it to humidity, and then we'll say cout and we can just call our function here right in the cout. And this will return the humidity. We need to pass in the weather data and the number of lines of data we have. And so this will display the average humidity. Let's see if it works. And we can see we have the average is 37. If I look at this data, I suppose that makes sense. We could also, if you wanted the average temp, it'd be the same thing, except that we would be looking at the temperature instead. Just that little bit of a change, copying the function over. And of course, at this point, we would probably want to show all that data. We have humidity and temperature. We look at the temperature values. Yeah, it looks like it makes sense. So now we have average temp. Other functions that you could do to do calculations is maybe calculate a max. How do we do max temp? Same thing, we're going to loop through, we're going to say, and you can either start at 0, but I find that probably the safest bet is, because let's say we had negative numbers for data, is just say weather data index 0 dot. We're going to grab the first element and say that's the max temp. We'll start and then we'll start from there, and we'll go through. And for figuring out max, you basically have to use an if statement. If max temp, the current max temp is less than so if the current max temp is less than the one you're currently looking at in this loop, then what do you need to do? Well, what you need to do is say, the max temp is wrong. Max temp is therefore should actually be equal to this. And then we would return that max temp. So that would be a max function. Instead of totaling, what we're doing is we're just looking at each element and seeing if there's one that's higher. If it's higher, then we'll change whatever the max is to that value. Now we can see the max temp is 94. If I look through here, there's that 94.1. And I don't see any values that are higher than that, so that looks like that max temp calculation is working. So there we have, how we can do different calculations, and you can make all kinds, depends on what you're doing. If you can make pretty complex statistical functions here. It's just however you want to use this weather data collection to get information out of it. Now, the next thing we might want to do is maybe we want to save that information to a file. We've got the information file. If we want to save it to a file, let's make a function for that. And so for that, we're going to, again, whenever doing with functions, it's a good idea to return a Boolean to say whether it actually worked. And with the right function, basically what you're going to pass in, you're going to pass in the file name, because you're going to need that. And then whatever you want to write. And so let's see, maybe we want to write, we want to show the average temp, the max temp, average humidity, and then writing a file is kind of the inverse of reading from a file. You're going to, instead of an IF stream object, you're going to create a OF stream object. I'm going to call it out file, and then we're going to open that output file. We're going to use the file name that's passed in this case, and then we're going to check to see, of course, if the file opened. Always check because it's not automatic. And if it's open, if it's not open, what we'll do is we will display an error, or we'll just return false. We won't display an error. We'll let main display the error. If we want to, if it does work open, then all we're going to do is output our results. And we're going to use the same methods that we would if we were writing to see out. I'm going to put some end lines in here. So just the same rules that apply to cout are going to work with your output file. So you already know most of what you need to write to a file. So this is going to write, we're going to open, we create an OFStream object, we use the open method to open up our file. We check to see if it's open. If it's open, we just write to it just like with cout. If we can't open it, then we just return false from this function. Again, take the prototype, save it to your .h, and then just use it in your function. So here, maybe after we do this, we will just call that right. And before when we wrote to the file, we put the result into a variable, but you can actually just call that that function right inside of an if statement like this. And let's say we're going to call it something like that. So we could either create a variable name like we did up here, but you can also hard code the file name. It's probably better to do it this way. Let's create a string. And so rather than just passing as a hard-coded value, I'm going to just put it here. So we need to put the output file name, then the average temp. Notice that IntelliSense will tell you what your parameters are, so that's kind of helpful. So for average temp, what do we call it? Oh, we didn't store it here, so it probably would be useful to change these function calls to put them in variables. So I can reuse them. And now we have those to reuse. So I can say average. So first one is average temp, max temp. And it's useful to use that IntelliSense. So just to make sure I don't get these out of sequence, I can look at what it's looking for and then find the variable that most closely that I want to pass in for that. And even though these are different names, that's the one I want in that position. And so I'm going to check the results of this write data. If it comes back true, it means I successfully wrote it, and I'll just tell the user something like file saved to else So we'll try to write the data. If it's successful, we'll tell the user we successfully saved it. If this returns false from here because it couldn't open the file or couldn't save the file, then we'll just tell the user in main that it could not be saved. So notice we're doing the communication from main. We're not doing the communication from inside the functions. And file saved to weathersummary.txt. So if I go now and open up that file, I can go to the Solution Explorer, right click on my project, open the folder in File Explorer, and there's the weather summary. Edit with Notepad++, and we can see that it did in fact write down those averages and store them in the file. So that's how we write to a file. So we've seen today how we can open up a file. We can write a function to read from that file. How we can calc some statistics using some functions and then write a summary to that file. This completes this demo. Thank you.